Good morning to Dr. Aslina and my course mate. We are from Group 2-2 and in today's agenda, we will be presenting on topic 3 which is data description. For today's topic outline, we will learn on measures of central tendency, variation, position, and exploratory data analysis. As for the learning objectives, the objectives for today's topic will be reached once students are able to summarize data using central tendency measures, such as mean, median, mode, and mid-range. Describe data using variation measures such as range, variance, and standard deviation. Identify position of a data value in a data set using various measures of position, percentiles, deciles, and quartiles. And lastly, using techniques of exploratory data analysis, box plot, and 5-number summaries to discover various aspects of data. The measures of central tendency, variation, and position that will be explained in this topic are part of what is called as traditional statistics. So what is the meaning of average? An average means the center of the distribution or the most typical case. Measures of average are also called as measures of central tendency and include the mean, median, mode, mid-range, and weighted mean. Statistics are known as characteristics or measures that is obtained by using data values from a sample whereby the sample is a smaller group taken from the population, while parameters are known as characteristics or measures obtained by using all data values for a specific population where it is the entire group that you are interested in studying. Moving on to the general rounding rule. So in statistics, rounding should not be done until the final answer is calculated. The use of parentheses on calculators or spreadsheets helps in avoiding early rounding error. There are specific rounding rules for many statistics and they will be given in the appropriate section.
Assalamualaikum, good morning and hi everyone. Today we will learn an interesting topic which is the measure of central tendency. The first measure of central tendency that we will learn is mean. I'm sure in our secondary school we have heard the word mean. But what is mean? Mean is the quotient of the sum of the values and the total number of values. In simple terms, we can find the mean by calculating the sum of the value of data and dividing it with the total number of values. Okay everyone, you need to remember that there are two symbols that represent the mean, which are the X bar symbol shown on the left side and the mu symbol shown on the right side. The mu symbol is taken from the Greek letter. The X bar symbol is used to find the sample mean and the mu symbol is used to find the population mean. Before I explain further, it is important for us to know the formula to find the mean in a set of data. The formula to find the sample and the population mean are shown on the slide. Don't be afraid, it looks confusing, but it is easy to use the formula after we go to the example later. The formula that we only need to memorize is shown on the slide right now. The sigma represents the sum of value of data, the X symbol represents the value of data, and the N symbol represents the total number of values. Without wasting time, let's go to the question. The number of calls that a local police department responded to for a sample of 9 months is shown. Find the mean. So, the solution is shown on the slide. First, we need to write the formula. Next, follow the formula, write all the values that are given for us from the question, and divide it by 9. Why 9? Because the question asks only for 9 months. After that, place a calculator to find the answer. So, the mean number of incidents is 693.7. The mean should be rounded to one more decimal place than occurs in the raw data. For example, if the raw data are given in whole numbers, the mean should be rounded to the nearest tenth. If the data are given in tenth, the mean should be rounded to the nearest hundredth, and so on. The mean in most cases is not an actual data value. Next, we proceed to find the mean for group data. We need to follow a few steps to find the mean for group data. Step 1 is to draw a table consist of 4 columns. The first column is the class, second column is the frequency, the third column is the midpoint, and the fourth column is the product of frequency and midpoint. 2. Find the midpoint and place it in the third column. Step 3. Find the product of frequency and midpoint for each class and place it in the fourth column. Step 4. Find the sum of product of frequency and midpoint and place it in column D. Step 5, which is the last step, is to find the sum of product of frequency and midpoint and divided it by the sum of the frequency from second column. Formula for the mean is shown on the slide. That's all from me for today. Thank you.
Hello, so now we have to take a look at the example of the mean question. Below is a frequency distributions of miles run per week. Find the mean. So given is the class boundaries and the frequency. Following the procedural table, first we need to construct a table which consists of A for class, B for frequency, C for midpoint, and D for frequency times the midpoint. So A and B column is given in the question, and C is we need to find the midpoint for each classes. So here we have found all the midpoint for each class, and D column here is basically just multiply the frequency and the midpoint together. So we've done that here, and the total of the frequency times the midpoint here is 490, and the total of frequency N here is equal to 20. Using the formula to find the mean, just put the total of frequency times the midpoint that we have found in the table. So 490 over the N, which is 20. So the answer is 24.5 miles. Median. So the median is the midpoint of the data array, and the symbol used for median is MD. Steps in finding the median. Here we have to take a look at this while doing the example. So example 1. The number of police officers killed in the line of duty over the last 11 years is shown. Find the median. So first step is we need to arrange the data value in ascending order. So here we've done that here. So the second step is to determine the number of values in the data set. So number of value is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So n equal to 11, which is odd. So if odd, select the middle data value as the median. So the middle value here is 157. So the median is 157. Question 2. The number of tornadoes that have occurred in United States over an 8-year period follows. Find the median. So the first step is to arrange the data in ascending order, and the second step is to find the number of data value 1, 2, 3, 4, 5, 6, 7, 8. N equal to 8, which is even. So if even, then we need to find the mean of the two middle values. Two middle values here is 764 and 856, and we just adding them together over 2. So the answer is 810.
Hello, my name is Nurul Ailiana binti Alilor. I'm going to continue the presentation on mod. So mod is the value that occurs most often in a dataset. A dataset that has only one mod is called unimodal. If it has two mods, then it's bimodal. Many mod, it's multimodal. And when no data value occurs more than once, we don't say the mod is 0. Instead, we say the dataset has no mod. Next, I'm going to show you how to find the mod. For example 1, find the mod of the signing bonuses of 8 NFL players for a specific year. The bonuses in millions of dollars are, we are given 8 values here. So the first thing you have to do is sort the data in ascending orders. It's not necessary actually, but it is very helpful because it will make it easier for you to count and see which value occurs the most. As you can see, after the data is sorted, number 10 occurs most often, which is 3 times. So the mod is $10 million. In this case, the dataset has only one mod, so it is unimodal. Alright, for example 2, the data show the number of licensed nuclear reactors in the United States for a recent 15-year period. Find the mod. There are 15 values given here. Again, we have to sort the data in ascending order. After that, you can see 104 and 109 both occur most often, which is 5 times. So the mod are 104 and 109. Since we have two modes here, this dataset is bimodal. Next, for example 3, this is how to find the mode for group data. The mode for group data is the model class, the one that has the largest frequency. So the question, find the model class for the frequency distribution of miles that 20 runners ran in 1 week. Look at the frequency, and the largest one here is the number 5. So the model class is 20.5 until 25.5. Or sometimes we also can use the midpoint of the model class. The midpoint of the model class is 23 miles per week. That's it for the mod. I will pass to the next presenter.
Hello everyone, my name is Fadil. So here is the another example question for the coefficient of variance. So here is the question. The mean for the number of pages of a sample of Women's Witness magazines is 132, with a variance of 23. The mean for the number of advertisements of a sample of Women's Witness magazines is 182, with a variance of 62. Compare the variations. So here is the solution. So the first thing to do is we need to use the formula CVAR equals to standard deviation over mean times 100%, so that we can get the coefficient of variation. Because the question give variance, so we need to square root the variance to get the standard deviation. And after that, we just take all the values from the question into the formula. And after we insert all of them, then we can get the answer. So here is the answer. 3.6% pages and also 4.3% advertisements. So after that, we have to make a conclusion. So here is the conclusion. The number of advertisements is more variable than the number of pages. So next we have another measures of variations that is called range rule of thumb. So this range rule of thumb is basically approximates the standard deviation as this formula. So the formula is S approximately equals to range divided by 4. So the condition to use this formula is the distribution is unimodal and approximately symmetric. And this range rule of thumb is also a simple way to calculate the range using standard deviation. It also tells us that the range is around 4 times the standard deviation in most cases. So if our standard deviation is 2, then our range is probably about 8. So here, how do we use the range rule of thumb to identify the limits separating values that are smallest data value as well as the largest data value? So to find the smallest data value, mean minus 2 standard deviation, and to find the largest data value, mean plus 2 standard deviation. Next, we have another measures of variation that is called Chebyshev theorem. So this Chebyshev theorem is the proportion of values from any dataset that fall within k standard deviations of the mean will be at least 1 minus 1 over k square, where k is a number greater than 1, and also k is not necessarily an integer. So it tells us that any dataset's proportion of values falling within k standard deviations of the mean will be at least 1 minus 1 over k square, where k is a positive integer. So this is a table that shows the D10. So what we have here is for the first column is that k equals to 2, k equals to 3, and k equals to 4. The k start with 2 because it said here that k is a number that greater than 1. And for the second column is the minimum proportion within k standard deviations. So how to find this one? We will use the formula 1 minus 1 over k square and use the k value to find the minimum proportion. So for the k equals to 2, 1 minus 1 over 4 because 2 power of 2, right? And the answer will be 3 over 4. Same goes to another 2 k value. So after we get the minimum proportion, we can times with 100% and then we can get the minimum percentage. Same goes to another 2 value. Here is the Chebyshev theorem looks like in graph form. Here we have the mean in the middle. On the right side, we have mean plus 2 standard deviation as well as mean plus 3 standard deviation. And in the left side, we have mean minus 2 standard deviation as well as mean minus 3 standard deviation. And according to the table before, at least 75% is the minimum percentage within k standard deviation. And here, get from mean minus 2 standard deviation to mean plus 2 standard deviation. And at least 88.89% is from mean minus 3 standard deviation to mean plus 3 standard deviation.
The mean purchase of a house is creating neighborhood is $15,000 and that standard deviation is $10,000 find the purchase rate of which at least 75% of the house will sell. Solution Chebyshev theorem see that 3/4 or 75% of the data values will fall within the 2 standard deviation of the mean. Thus, $15,000 plus 2 times $10,000 dollars is $17,000 and $15,000 negative to timing $10,000 is $13,000. At least 75% of our home slot is air will have a price and regular of $30,000 to $17,000. A series of location companies found that the mean amount of travel along with excrete with $0.25 per mile. The standard deviation was $0.02 using Chebyshev-Snell found the management percentage of the data values that will fall between $0.2 and $0.3. Solution: the step 1 subtract at mean from the larger value. $0.3 negative $0.25 is $0.05. Step 1. Step 2, divide the difference by the standard deviation to get K. K is 2.5. Step 3, use the Chebyshev-Snell to find the percentage is 84%. At least 84% of the data value will fall between $0.2 and $0.3. The Ampere rule, Chebyshev-Snell applies to any distributed regression of its share. However, when a distribution is being shared, the following experiment with makeup is the empirical rule are true. Empirical statement: 68% of data values will fall with one standard deviation of mean. Empirical statement: 95% of the data values will fall with two standard deviation of the mean. The empirical statement: 99.7% of the data values will fall with the three standard deviations of the mean.
This is called a standard score, that the value obtained by subtracting the mean from the value of and dividing the result by the standard deviation. The symbol of a standard score is Z. Okay, the formula is Z equal to value minus mean divided standard deviation. This two symbol is for sample and for population. So a Z score is represent the number of standard deviation that a data value falls above or below the mean. Okay, for the purpose of this session, when we find the Z score, the data will be obtained from the samples. Let's look at the example. Okay, a student scored 85 on an English test, and then the mean score for English test is 76, and then the standard deviation is equal to 4. Okay, she also scored 42 on a French test. Okay, plus mean for the French test is 36, standard deviation is 3. By using the formula given, Z equal to value minus mean equal to 85 minus 76. Divide 4, we get the answer 2.25 for French test. Okay, Z equal to 42, that the score for the front test minus the mean for the front test is 36, divide the 3, you will get 2. So this score for English test is higher than the front test, then the relative position on English test is higher than front test. Okay, next is percentage. Percentage is separate the data in 100 equal groups. Okay, this one is the percentage formula. Percentage equal to number of value below S plus 0.5 divide total number of S, total number of value times 100. Example 3-30. Okay, the number of traffic violation recorded by a police department for a 10-day period is shown. Find the percentage rank of 60. So this list is in order list, so we need to arrange the data from lowest to highest. So from 9, 12, 15, 16, 18, 19, 20, 22, 24, and 25. This is the order list. By using the formula, percentage equal to number of value below S plus 0.5 divide total number of S and total number of value times 100. So we calculate 9 as 1, 12 as 2, 15 as 3. So after that we get 16. So 3 plus 0.5 divide 10, because we have 10 value in this. So times 100 we get 35 percentage. Okay, hence the value of 16 is higher than 35% of the data value. That's all my presentation. Thank you.
Hi everyone, my name is Tiuchun and I'm going to talk about the example of 3 for 32 test score. A teacher gives a 20-point test to 10 students and we need to find the value corresponding to the 25th percentile. The value given is 18, 15, 12, 6, 8, 2, 3, 5, 20 and 10. So at first we sort it in ascending order. So after we sort it, it will become 2, 3, 5, 6, 8, 10, 12, 15, 18 and 20. So we will, for finding the value corresponding to the 25th percentile, we will using the formula of C equals to M times P divided by 100. So we use 10 multiply 25 and divide by 100 and it will equals to 2.5 and similar to 3. So the third value, so the value 5 corresponds to the 25th percentile because number 5 is the third value. So the next one will be measures of position, quartiles and deciles. Deciles separate the data into 10 equal groups while quartiles separate the data into 4 equal groups. So the interquartile range is the third quartile minus the first quartile. And next is how to find data values corresponding to quarter 1, quarter 2 and quarter 3. So for the step 1, we need to arrange the data in ascending order. That's mean from lowest to highest. And step 2, we need to find the median of the data values, quarter 2. And the step 3 is we need to find the median values that fall below quarter 2, which is the quarter 1. And step 4 is we need to find the median data value that fall above quarter 2, which is quarter 3.
Hi everyone, now we are going to look into the example for quartiles. Find first, second and third quartile for the data set. First step, we arrange it in ascending order. Next, find the median of the data values. And this is the value for second quartile. Then, find the median of data values that fall below the second quartile. And that is the value for first quartile. And final step, we find the median of data values that fall above the second quartile. And that is the value for third quartile. Okay, next, measure of position, outliers. Outliers are data values that are far from other data values, whether extremely high or low data value. As we can see in the graph below, they can distort statistical results. An outlier can be considered as a data value that less than first quartile minus 1.5 interquartile range or greater than third quartile plus 1.5 interquartile range, as we can see in the diagram below. 3.4 Exploratory data analysis. The 5-number summary is composed of the following numbers: minimum, first quartile, median, third quartile, and maximum. They can be graphically represented using a box plot. So how to construct a box plot? Here we have an example. First, we arrange the data in ascending order and find the 5-number summary, which are the minimum, first quartile, median, third quartile, and the maximum. And here are the 5-number summary. So first step, to construct a box plot, draw a horizontal axis with a scale that includes the maximum and minimum data value. Next, draw a box with vertical sides through first quartile and third quartile, and draw a vertical line through the median. Next, draw a line from the minimum data value to the left side of the box, and finally, a line from maximum data value to the right side of the box. And our box plot is now complete. That's all from us. Thank you.
Alright, thank you Group 2-2, and let's proceed to the fourth measures of central tendency, which is mid-range. So as you can see here, this is the formula, and it is a very simple formula including only addition and division. Or in simple words, I could say mid-range is the calculation to find the average of the highest and lowest values in the data set. So let's look into an example to see how we can apply mid-range formula in real life example. So this question here states that, let's say there's 5 students in a class A. scored 90, 75, 64, 88, and 71 for mathematics subject. So what we need to do is to find the mid-range. So as simple as this question is, it only involves two steps, which is first identification of both the lowest and highest value, which we can clearly identify it. Here is 64, which is the lowest. Let me draw it here, and then highest is 90. Alright, with that being identified, we can straight away apply the formula where 64 is put here, and then highest 90 is put here, and then since it's average, we are going to divide by 2, and hence we are able to calculate that the answer is 77. Alright, easy, right? So let's move on to something even complex, which is weighted mean, and I will say it's the last measures of central tendency. So as you can see, the formula is a bit complicated, but let's go dive into what it actually is, which is weighted mean of a variable is found by adding the product of value x with its weight w, then divide by the sum of weights. So as you can see here, yeah, it's adding, right? So yeah, there is addition in all of the products of w and x. So as you can see here, it's the same for all of the multiplication, and then we divide it by the sum of all w's. So yeah, as simple as this formula is showing us. So maybe again, let's look into the example in here, which the questions already gave us a very clear table showing the grades scored by the students in class A. So what we need to do is actually calculate the average of grade points scored by one student. So again, two simple steps. One is identification. So first we need to find what is w and what is x. So in this case, we are putting w, which is the number of students. This is w, and then the grade is value x. So here, which basically means all these pointers are x lah. So yeah, since we already identified, all we need to do is applying the formula. So here is the formula. And yeah, maybe a quick maths, 15 times 4 is 60, and then 20 times 3 equals 60, and then 5 times 2 equals 10. So the addition of all this is how much? 130, and then divided by the sum of all w, which is 15 plus 20 plus 5, which is how much? 25, 15, quick maths, 40. Alright, so yeah, that's a bit unclear there. Oh yeah, so the answer is 3.225, and voila, that's the answer. So yeah, that's all for me. Thank you.
Now let us move to properties and uses of central tendency. The first one is the properties of mean. The mean is found by using all values of data. The mean varies less than median and mode. The mean is used in calculating other things such as variance. The mean for the data set is unique, usually not one of the data values. The mean is affected by extremely high or low values called outliers. Next is the property of median. Median gives the midpoint and is used when need to find out the data values fall into lower half or upper half of distribution. The median can be used for open-ended distribution. An open-ended distribution means that one or more of classes is open-ended. In other words, it does not have a boundary. For example, in this frequency distribution table, a week of 57 or less in the first row means this is an open-ended distribution. Lastly, median is affected less than extremely high or low values when compared to mean. Here is the property of mode. The mode is used when the most typical case is desired. The mode is the easiest average to compute. Also, the mode can be used with nominal data, and mode is not always unique or may not exist for a data set. Lastly is the property of midrange. The midrange is easy to compute, give the midpoint, and is affected by extremely high or low values in a data set. Okay, let us proceed to range. Here is the simple formula for range. It is used to find the difference between the highest and lowest values in a data set. Okay, let us have a look in this example. Let's say there are 5 numbers which are 10, 5, 9, 6, and 3. So how do we find the range? First, we identify the highest and lowest value. In this example, the lowest value is 3 and the highest value is 10. After that, we apply the formula range equal to highest minus lowest. So we get 7 in this example. That's all for me. Thank you.
Hi, so I will be presenting the measure of variation, variance, and standard deviation. So population of variance is the average of the squares of the distance each value is from the mean, and the standard deviation is the square root of the variance. So this formula, right? So the uses of the variance and standard deviation is to determine the spread of the data, the consistency of a variable, and the number of data values falling within a specific interval in a distribution. So Chebyshev theorem, and it's also used in inferential statistics. So formula of variance and standard deviation in population of theoretical models. So there are two types of formulas. One is for the population of variance, and another one is population standard deviation, like this. And like this. So I will be explaining each of the symbol. One is sigma. Sigma is the symbol of population standard deviation. And then capital sigma is the sum of the equation. Capital X is the data value. Mu is the symbol of mean. So it's a representation of the mean lah. And then N, capital N is the cumulative frequency, total of the data values. So steps to find the population variance and population standard deviation. Okay, we have 6 steps. We have to follow these steps accordingly. So first step is to find the mean using this formula. Second step is to find the deviation using this formula. Third step is to find the square value of the deviation. So you just have to square it. And then step 4 is to find the sum of the square. So sum. And then step 5 is to use the population variance punya formula to find it. And then lastly is our step 6, which is the population standard deviation. So we must use this formula lo. So as an example, one question, one of the experimental brand of outdoor paint, brand A, is tested to see how long each will last before fading. 6 cans of paint constitute to a small population. The results in months are shown 10, 60, 50, 30, 40, and 20. So they are asking us to find the variance and standard deviation of the results for brand A paints. So step 1, as I've said before, you have to find the mean using this formula right here. So in case the result already has shown each of the cans, so 10, 60, 50, 30, until 20, right? So we just have to total it up. We will get 210. And then after that, you must divide it with the cumulative frequency, which is 6. Because 1, 2, 3, 4, 5, 6. So, and then after that, you will get your mean, which is 35. So step 2 is to find the deviation of the results each can. So we must use the formula for deviation law. And then after getting it right, we must minus the months with the mean. So you will get negative 25, then 25, 15, 5, and negative 15, like this. So you just put it in your table law. So next step is to find the square of the deviation. So or after you already found your deviations, right, you just have to square it. So you will get 625, 625, 225, 25, 25, and 255. So you just put it in the table like this. And then step 4 is to sum up all the squares of the deviation. So once you already get your square of deviation, right, you just have to total it up all together, like so, like this. And then your answer will be 1750. This is the sum law. And then step 5. So you want to find the population variance now. We must use this formula already given to us. So we got total up everything, right? 1750 just now. And then we have the cumulative frequency, which is 6. So you will get the answer 291.7. And then 6 is to find the population standard deviation. You use this formula over here. And then just square root law from the answer before, 291.7 square rooted equals to 17.1. So formula of variance and standard deviation in sample theoretical model. Okay, we have 2 different formulas as well. One is sample variance and sample standard deviation. So S represents the simple standard deviation for sample. The capital sigma is a sum. X is the data value, X bar is the mean, and then N is the number of samples. So variance and standard deviation in sample computational model it's mathematically equivalent to a theoretical formula. It saves time when calculating by hand. It doesn't require the value of the mean, and it is more accurate when the mean has been bounded. So formula of variance and standard deviation in sample computational model is two formulas again, sample variance and sample standard deviation. So it's almost the same thing as before, and then just that the formula looks a bit different. You just have to substitute all of the numbers inside it, and you will get the both of these. So measure of variation, coefficient of variation. Okay, the coefficient of variation is the standard deviation by mean expressed as a percentage. So this is the formula of coefficient variation, C-var. So use C-var to compare the standard deviation when the units are different. So when the units are different, we have to use this formula so that it's easy for us to compare. So as an example, sales of automobiles. Okay, the mean of the number of sales of cars over the 3-month period is 87, and then the standard deviation is 5. And while the mean of commissions is 5,225, and the standard deviation for that is 773. So compare the variations of the two, right? So we must use this formula right here. We already know the standard deviation and also the mean. So we just use this. We just substitute the numbers in times 100%. You will get 5.7% for sales. Same goes for the commissions. You already know it's 5,225 for, and standard deviation is 773. So when you substitute in times 100%, you will get 14.8% for commissions. So conclusion is that the commissions are more variable than the sales.